Okay, when it says nth term of linear sequence, it means what's the rule that you can use to go from the position in the sequence to the actual term. And the fact that it's linear means it goes up by a constant amount each time. So I can actually spot this. I can look at this is called the first difference. If I find the difference between these terms, it goes up by +3 +3. Now so does the 3 times table. So it's going to be a bit like 3n, because if I have just 3n by itself, then it would be 3 when n is 1, 6 when n is 2, 9 when n is 3. I don't have that. I start with 8 instead. And I can see it like this 3 times table, but it's sort of been moved. So this is, this is 3 times 1 plus something, 3 times 2 plus something, etc. And to work out what the something is, I can go back to the 0th term. So I can actually minus 3 going back this way, which is going to give me 5. And the answer then is 3n plus 5. It's actually the 3 times table, but I've shifted up 5 along the number line. That's my answer for the nth term. Next bit is a quadratic sequence, and they've told me that it's in the form pn squared plus qn. Normally you get like an extra constant term as well, but they're basically saying in this question there is no constant term. Okay, the way I'll do this question is that first of all, I know that it's going to be quadratic. I know the second difference is going to be constant, but let's just find out what it is. So it goes up by 12, then it goes up by 22, then it goes up by 32. That's the first difference. You can see it's now not constant. And then the second difference, this goes up by 10, and brilliant, it goes up by 10 each time. Okay, to deal with pn squared plus qn, I'm going to do exactly the same for this sequence, and I'm going to get it in terms of p and q. So when n is 1, I just get p plus q. When n is 2, I'm going to get 4p plus 2q. And I could actually at this point create simultaneous equations for p and q using the 2 and the 14, but I'm going to continue to solve it like this sort of standard way that I teach to solve this kind of question, because we're able to get p much quicker then, much more easily, I'd say. So when n is 3, I substitute that in, I'm going to get 9p plus 3q, and that's enough. Now I can find my first difference, which is 3p plus q, my second difference, which is 5p plus q, and my second difference is 2p. And I can now directly compare that 2p, let me do a different color here. I can directly compare the 2p with the 10, and that's going to mean I can write down 2p equals 10, so p is equal to 5. Okay, what's left? Now I just need to compare 3p plus q with 12. So I can do that over here. 3p plus q equals 12, but I know what p is. So it's going to be 15 plus q is equal to 12, and I can rearrange this to get q is equal to minus 3. There is no constant term here. So if there was, then you would expect to then substitute in for this bit here, p plus q, but it would be a plus b plus c for a more general quadratic with a constant term. We don't need to worry about that here. Just need to fill in the final answers, 5 minus 3, and we are finished.